Newton, they are acting due south, that is in the downward direction. So as you can see over here, we have shown these two forces of 15 Newton and 10 Newton which are acting due south, that is in the downward direction. Now it is given that the distance between the forces is 2 meters. Now we have chosen the space diagram scale as 1 centimeter is equal to 0.5 meter. So you can see this 2 meter is the distance between these two forces divided by this 0.5. So 2 divided by 0.5, so that will be 4, and by scale we can have the distance between these two forces as, that is this 15 Newton and 10 Newton. This distance between these two forces is 4 centimeter by our space diagram scale, because our space diagram scale is 1 centimeter is equal to 0.5 meter. Now let us select the Bow's notations A, B and C. It means that in this particular case, this 15 Newton force is represented by this AB, then this 10 Newton force is represented by this BC on our vector diagram. Now let us first draw the vector diagram over here. Now we'll select the scale. So vector diagram scale is 1 centimeter is equal to 2.5 Newton. Now as we have seen earlier that this 15 Newton force is represented by this AB. So this 15 divided by the scale that we are having, scale is 2.5. So 15 divided by 2.5, so that is 6 centimeter, and therefore this vector that we have drawn, that is this AB, is of 6 centimeter. Similarly, this BC is representing this 10 Newton force. So 10 divided by this 2.5, that is 4 centimeter. So this BC length of the vector is 4 centimeter. Now from this start point A up to this end point C, this total distance is the distance of the resultant R. Now join this OA. So as you can see over here, we have selected any point O which is known as pole, and we have joined this O with A. Similarly, this O with B and this O with C. Now we have drawn a line parallel to this OA. So this is our OA, and we have drawn a line parallel to that OA in the space A. Similarly, in the space B, we have drawn a line which is parallel to this OB. So this is our OB, and to that we have drawn a line parallel over here in the space of B. Similarly, we have drawn a line parallel to this OC in the space of this C. So this is our line which is parallel to OC. Now extend this first and the last line. They will intersect each other over here, and this is the position of the resultant. Now we'll find out this distance x. So we can find out the magnitude of the resultant as well as location or position of the resultant from 15 Newton force. So R is given by, as we have seen earlier, this R is given by length AC. So from A to C, it is length AC multiplied by this vector diagram scale, that is 2.5. So as we have seen earlier, AB is 6 centimeter, BC is 4 centimeter. So 6 plus 4, that is 10. So it is 10 into 2.5, that is 25 Newton. Similarly, we can measure the distance x, and this distance x, when we measure, it is 1.6 centimeter, but our scale is 0.5. So 1.6 into 0.5, so that is 0.8 centimeter from 15 Newton force. So this distance x is 0.8 centimeter from this 15 Newton force. Now let us draw this actually on our graph paper by using some different scales. Let us try to understand how to draw it actually on our graph paper. So here we have shown the 15 Newton and 10 Newton forces, and the distance between them is 2 centimeter, because the scale that we have chosen is 1 centimeter is equal to 1 meter. Now these are the Bow's notation that we are drawing. So AB is representing 15 Newton force, this BC is representing 10 Newton force. The vector diagram scale that we have chosen is 1 centimeter is equal to 5 Newton. So our first vector will be 15 divided by this 5, that is 3 centimeter. So this AB will be of 3 centimeter, as you can see over here. Similarly, this BC will be of 2 centimeter. Now take pole O, join this OA, OB and OC, as you can see over here, and draw a line parallel to this OA in the space of A, and parallel to OB in the space of A, and parallel to OC in the space of C. Then extend this first and the last line, as we have already seen. So this will, the intersection will give the location of the resultant. AC, and multiply it by this scale of 5 Newton. So AC is 5, in this case 5.1. So R is equal to length AC, that is this particular length AC, multiplied by vector diagram scale, that is 5. So vector diagram scale is 5 over here. So 5 into 5, that is 25. So in this way we can find out the resultant of the two like parallel forces. Now let us see how to find out the resultant of these three forces, 100 Newton, 200 Newton and 400 Newton, which are acting at a distance of 2 meter and 3 meter, as shown over here on the diagram. Now we are having this Bow's notation. So this AB is representing 100 Newton force. Similarly, this BC is representing 200 Newton force, and CD is representing 300 Newton force. Now we have taken the vector diagram scale as 100 Newton. So we can say that this AB, which is representing this 100 Newton force, so 100 divided by this 100, so that is 1 centimeter. So our AB length will be of 1 centimeter. Similarly, this 200 divided by 100, that is 2 centimeters. So BC, vector BC will be of 2 centimeter in the upward direction. That also we have shown. And similarly, this 300 Newton force is represented by this CD, and so vector CD will be of 3 centimeter, because our scale is 1 centimeter is equal to 100 Newton. So this 300 divided by 100, that is 3 centimeter. So this vector will be of, CD vector will be of 3 centimeter. Now choose any point O, correct, and join OA, OB, OC, OD as usual. Now in the space of A, first we'll look at this resultant R. Now in the space of A, we have to draw a line parallel to this OA, so that we have shown over here. So this is the space of A. So in the space of A, draw anywhere a line parallel to this OA. Then draw a line parallel to this OB. So this is our OB ray. To that we have drawn this line parallel in the space of B and touching this initial point of this. Similarly, draw a line parallel to OC, and that we have shown. So OC is this particular line. Draw a line parallel to this OC in the space of this C. Similarly, draw a line parallel to OD. So this is OD. To that we have drawn a line parallel to that OD in the space of D. Now extend this initial line. So this is our initial line and this is our final line, or initial ray and final ray. So extend this. They will intersect each other at this particular point. So that is our resultant R. So R will pass through that particular point. You can measure the distance of R from 100 Newton force, and then R is given by, in magnitude it will be nothing but the starting point, as we have seen it is A to D. So that distance is 6, and multiply by the scale, vector diagram scale, that is 100 Newton. So 6 into 100, so that is 600 Newton. Similarly, you can measure this distance X from 100 Newton force, and the distance comes out to be 3.25 centimeter. So in this way we can find out the magnitude, direction and position of the resultant in case of the like parallel forces using the space diagram, vector diagram and funicular polygon. Thank you very much for watching. Do subscribe to our channel.